Hello YouTube, this is Frank, and this is September the 8th, 2020, and this is my 40th video and my second text editor video. And I will be talking about the TDE 5.1V editor. And I'm going to compile TDE 5.1V in a 64-bit Ubuntu operating system. The versions, TDE 5.1V, Windows 64-bit. That's this back here. I've got Windows 7 64-bit, Ubuntu 64-bit 19.1.10. On my Windows, I've got memory.c GCC 4.6.2 30-bit compiler, and I've also got OpenWatcom 2.0 version 2.0 from January 2020, and I'm going to be using the 32-bit code from that. I like the OpenWatcom compile environment in Windows 7. I think I like the debugger in that package. I'm not sure if MinGW has a debugger. Let's see. And Ubuntu, I'll be using GCC 9.2.1 64-bit compiler, and I've also got CLang 64-bit over there. So let's see what we've got. Now this is Oracle's VirtualBox, and I've got several different versions of Linux, or I've got several different Linux distributions in my VirtualBox, and I will be running Ubuntu 19.10 in a 64-bit environment. So let's see what we got here. Let's just check our GCC version. 4.6.2. Let's just check our Windows. Windows OS get OS architecture, Windows MIC OS get OS architecture. There we go. I spelled it right. There's our Windows 7 64-bit. Let's see. I've got TDE 5.1V in a directory. That's the zip file. Just search for that on the internet. You should be able to find the source code for TDE 5.1 on the internet. And I've got a simple program, a C program, to check the sizes of things. That's going to turn out to be very important when we look at the differences between the 32-bit compilers and the 64-bit compilers. So let's extract it. Okay, there's our source code. Now I am going to rename this original. If I make some mistakes in my coding, I can go back to the original code. Now I'm going to get the working directory. Let's see. And I'm going to rename this Watcom Okay, so let's go into here. Okay, here's our source code. If we sort by the date, you can see there's that May 2007 for that release date. Let's sort by name. Now this is my Watcom. I just go to the VNNT64 and I just click on the IDE. I'm not sure I've got it set up correctly, but that's the way I launched that. So let's start us a project, and we're in the TDE 5 Watcom direct. Let's call that TDE 51B. A Watcom. Maybe let's call it Watcom. And I want a character mode executable in the 32-bit environment, and that's our project name right there. So let's add our sources, and let's just add all of the C files. There's a whole bunch of those C files in that subdirectory, so let's just add all. We're going to be compiling in the Win32 environment, so let's go to that subdirectory and add all of those files to our project. Close. Okay, now we're ready to make our TDE, and you can see right here we've got an error. Let's go to our error, and it's complaining about the WinNT or Win32 define right here. So let's get out of this and go to options, compiler switches. Check our compiler switches, and let's go down to source switches. And this is where we can add our macro definitions, and that's Win32 underscore. Now I learned C in the mid-1980s, and Dennis Ritchie, he was one of the authors of the C language, and this was he wrote the book, and it was published in 1978. So I learned it from the one of the authors of the C language. Now on page 183 of the C programming language, he says a character or short integer may be used whenever an integer may be used. So I grew up with just having or assuming that characters would be signed, but we need and later though in the ANSI standard it's implementation defined. So anyway, we need to check this box right here, change to sign, because in Watcom in their implementation they're unsigned. Okay, we now in TDE, signed characters are used in the Boyer-Moore string search algorithm function. That's why we check that box. So now we can go back up here to actions, make. There we go. Can we get the error here? And it's complaining about the TC name. in Wattcom, we need the TZ name and not the underscore TZ name. So we need to get us some defines here. Let's get that. Let's get us a else. And we need us an end else. And let's see, we need, well, let's see here. Let's move this one right here. Yeah, there we go. Now let's get our TC name. Oops. Oops. There we go. All right. So let's make this Wattcom. To indent that, indent this, and indent that. And I'm going to put my initials out here. Oops. 0908. And that Wattcom C, that is a define in the Wattcom compiler there. So let's save this. Okay, now let's try to make all right. And we've got some warnings, but everything compiled. We can check on these warnings a little bit later. Those are just benign warnings right there. So if we come over to our directory here, change to TDE 51 VS Wattcom. And there's our executable. So we should be able to TDE 51 Wattcom. Yeah, and there we go. So let's look at this file right here while we're got this open. Well, let's get out of there. So we TDE runs. Let's just go back up to that directory right quickly. Let's compile that size of things. And there's that executable that we just created. So in a 32-bit environment, a long integer is the same size as an integer. A short is 2 bytes, character 1 byte, 4, and then the long is 8. Same with an unsigned integer. An integer is 4 bytes. An unsigned long integer is 4 bytes. And then here's the sizes of size T, pointer difference. The sizes of the pointers are 4 bytes. Now this is important right here. These are fixed width variables. Integers. Integer 8 is 1 byte. Integer 32 is 4 bytes. Unsigned integer, that just has the U right there. Unsigned integer. And those are fixed width storage. Okay, so let's see. Let's get over here. While we're here, let's debug this program because we want to. Let's just save some time. Let's just save some time and go over here to our modules. Let's load the memory. And this is the memory.c program, or memory source file. And this is what I was wanting to show. Up here at the top of the file, there are these characters, extended code characters in the comment section. So let's just take a note of that. Now let's go over here. Let's see. Let's just go down to our initialization. Let's see here. There we are. This is the initial memory function. When he first calls the memory manager, custom memory manager, he's going to initialize this. This is Jason Hood's memory manager, and he wrote this in 2001. And I don't think there were any open source 64-bit open source environments there. So he was just working with 32-bit environments. Let's go back down here to our initialize. There it is. There's our initialize the memory. Okay, let's go here and just stop right there. So let's go to run and go. Okay, now let's just stop at this init memory function. And so let's just step through here. We're going to step through here. And we're just initializing some global stuff right there. Now this is very important right here, that initial memory function. So let's expand block. And over here, let's add, let's insert some watch. And that's going to be, I want to look at block base 0 through 10. Block base, oops, block base 0. Okay, let's edit this. Okay, let's copy this. Let's insert, add a new one, and we want to do 1. Insert 2. Insert 3. insert, four, insert, 5, insert, 6, insert, 7, insert, 8, and one more, 9. All right, now let's watch this when we initialize his block structure right here. Okay, this the memory chunk. Let's see, block size. There it is, 6412. The base 0. There's that -1. Now we're going to set this to these over here to 12,250, and then 0 out these corners right here. Now this, to me, this is very difficult to understand this code. Those are macros, so you can't step into a macro. It's very difficult to see what the code looks like when we use macros, function like macros. But let's see here. Now that's the way that block is supposed to be initialized. So we get a 32-bit. We've got this. There's a -1. Now this is his next pointer. That's the previous. And here is the size. And that 250 times 2 to the 8th plus 12 times 2 to the 0 is 64,000 plus 12, which is 6412, and that is that 6412 there. That's how he gets the size there. So that's okay. Let me put that. These were zeros, 0, and 12 and 250. Now, if you want to learn more about these memory managers, and Donald Knuth, one of the classics of computer science, Volume 1, he does have some memory managers in there. But these two bytes here were for next, and then these two were the previous pointers for his memory manager. So let's go over here. I'm going to leave this right here, and because we're going to refer back to this and go over here to my Ubuntu. Let's see here. I'm going to unzip this, extract here, same thing. Let me rename it to Orig, and I'm going to extract it again and rename it to 001 ST memory manager. Okay, so over here, I believe I've got yeah, size of things. Let's just do our GCC version. There it is, GCC 9.2.1, and let's compile that. GCC. And there's our executable right there. That all right. Now, let's see if we can scroll up here. There's a long integer is 8 bytes, and a standard integer is 4 bytes. Now, in that 32-bit system, it was 4 and 4, and a short is 2 bytes. So let's look down here. There's the size T of things. There's the pointers are 8 bytes. But here in the fixed width variable types, there's no difference between the 64-bit and the 32-bit. If we wanted an int 64, it is 8 bytes on a 32-bit system or a 64-bit system. There's the unsigned integers. Okay, so let's go over here, and we want to get into this subdirectory, and let's edit this make file. There's Frank. So let's go over here. We are going to be compiling in Unix. And I just want, I'm not worried about a production executable right now. Let's just comment this out. And same thing over here that we did in the Wacom. 20200908. Let me just put my initials. Use so let's over here, let's add that F character flag. That's that box we checked over there in our Open Wacom. That's make sure we use signed characters for the default. And let's save. And come over here. Let's see. Change to TDE 0. Alright, let's just make it right, I think everything compiled. There's some warnings right there. Those are just warnings. Okay, so let's get down here. And there's our executable right there, TDE. And let's just run that. And it's let's go to our utilities, and let's see here now that I system monitor, and there it is. There's TDE. It's in some kind of loop somewhere, so let's just kill it. That's what happens whenever you compile TDE 5.1 in a 64-bit environment. It just it goes off somewhere. But let's debug that. Debug DDD with TDE. Now this is that GNU debugger. Okay, here's our debugger. And let's see. I wonder. Let's see, open source. And let's go to our memory. See, this is those special characters that I was talking about. This is that memory file. So let's get out of here. Yep, and let's edit this. And right here, see these, there's where it's hanging up there. Let's just delete that. Delete that, and then there's one more right here. Delete those special extended characters. Save it. And get out of here. And let's just make it again. Make. Now we made it with the that new source code, and debug it. DDD, TDE. All right, now let's see our file. Open source. Memory. Now that's better. These, let me just, while we're here, these are those function-like macros, and it's you can't step into those like a function and see what the actual code is doing. But anyway, let's go down here to our initialize. Oops. Initial memory right here. Let us stop, and we want to run this. All right, now let's step through here. All right, now this is that code that I was focused on, and the let me see here. Let me switch back over to Windows. So, yeah, right here, this is what we were wanting to look at, and there specifically the first 10 values, and then the, let's see here. So let's get back over there. Oh, here it is, and let's watch. Oops, let me see here. Graph, display, block, size. Okay, and let's see. And I'm just going to do the first 10. And I'm going to display those as unsigned, block, base, block, base, and I'm going to use the at key and 10. And this will get us that same display that we were looking at over there in the first 10 values of base. It's the same over here. Let's see. This is what we're looking at right here. We're initializing the memory, and let's just step through here. Next, there's our 6412. That's good. Base, there's that -1 right there. And let's look at these others. Okay, I'm going to step. Let's see, did I step next? Yeah, it's very difficult to see what they're with function-like macros. Those are function-like macros. It's very difficult to see what the code is doing with those things. Okay, there we go. There's that 250 and 12. So we just now initialized our size right there. Now let's go back over here to our. This is what it's supposed to look like. There's like a 12 to 50. Let's go back over here. Okay, now watch this right here. This line right here. I'm just going to step here, and boom. We just zeroed out the size right there. And the reason, now that was, let's see. Now I'm going to save some time here. There's all different, I mean, there's, we can spend a lot of time debugging this, but let's just continue. So the first time it allocates memory, and let's just step through here. Okay. Now, we're at this, just started this for loop right here. Let's display length, graph, display, size, and mem. Let's do that. Graph. All right. Now let's step through this for loop right here. You see that has the potential of being an infinite for loop. If we don't break out of that, it will never break out. That condition, It will never break out. So let's just step through here. Okay, len is 0. It's not greater than size. Okay, watch our memory. Let's see if mem changes. Nope, stays the same. Len. The size of the memory, see, it was zeroed out up here. Let's see. Oops, I lost my display up there. I restarted the program. But anyway, I think I still got it right here. Yeah, here we go. See, remember, it zeroed out this right here, the whole thing. It was 1, 2, 3, 4, 5, 6, 7, 8. A long integer is 8 bytes on a 32-bit machine. And so this is where this thing is going into that infinite loop. It zeroed out the size. So len is 0. We want the size of that's the size of our memory request right there. And there's 0. And the memory pointer here, that is never changing either. So there's where our infinite loop is, right here. Now let's get out of this. Now how do we fix that? We are going to use standard ints. This is right here. Let's include standard ints. Now this right, see, this is part of the C99 standard, 1999 standard, and Jason wrote that memory manager in 2001, so I'm not sure that standard int was part of any compiler that he had access to. So let's just put my initials here, FMD. Okay, right here. These are that. This is that. His defines. So let's go right here. Copy. Okay, I made a copy of those. Of that. Now let's. This is the original. Let me just put 200908. So the original defines. Oops. All right, now I saved a copy of the originals, and let's go back up here, and let's use those standard ints. Whenever we see an integer or unsigned integer, there's unsigned short. And we need an unsigned int 16. let's see. There's an unsigned short. Unsigned int 16 type short. Now this, be careful right here. Over there on that 32-bit system. Let's just go over there while we still got it open. See, an unsigned long is 4 bytes right here. So let's get back over here. This is where that, see, the double word. That's where that thing was messing up. 1, 2, 3, 4, 5, 6, and then 7, 8. It was zeroing out 8 bytes instead of 4 right here. So let's see. Let's make that unsigned int 32. Okay, let's see now. Do we have any more? Right here. Unsigned int 16. Okay, let's save this. Save. And come over here. Now let's make it. Make. Let's see here. Oops, did I do something? No, that's just a warning. Warning. Okay. So let's do them. Alright, here's our executable right there. TDE. Bam, there it is. TDE and a 64-bit Linux system. So that's just give us that file. Let's see, where's it at? There's memory. There's the one that was causing that trouble. There we go. Now that's one method of fixing the memory module. Now let's just go back out here. Let's get us, let's extract us another one. Rename this. No memory manager. Okay, so let's go in here. Let's see, that was change directory to 002. Okay, same thing. Let's go over here to our well, let's copy our mate file. And let's replace it. All right, let me look at this file here again. Yeah, there's our mate file. Here's our memory. Now this is the other method to fix that memory manager problem. Let's just take out the memory manager. Let's go down here to the bottom. Alright, let's start right here. Delete that. Go to the next, and that's a void. It returns a void. So let's go to our next subroutine. This next function, that's a void. Let's just take everything out of there. Delete it. Alright, the next function. Returning an integer. So let's go down here. Delete everything but the return. And let's just return a -1 right here. Next function, let's go up here. Next function looks like that's going to be an integer function. Yes, an integer function. So let's take everything out of it. Let's see here. And return a -1. Okay, next function. Looks like it's returning something. It's returning an integer. Return a -1 right here. Instead of font, just return a -1. Next function. Looks like it's returning some kind of pointer. Okay, this is that allocate function. Let's see. So let's delete everything in this function. Delete. Okay, here's our return, and we're going to return a null instead of that. Alright, the next function. Okay, there's probably an integer function here. Yeah, this is our init memory. So let's get rid of everything here, except for that okay. Okay, there's that one. Mem move, that is okay. We're not allocating anything. Mem copy, that's okay. Let's see, what is this? Reallocate, that's just over here. Let's just keep our reallocate. That's a standard C function right there. Let's see. Yeah, let's just delete that. If it's null, if it's not null, return memory. Can we do that? Oops. And we just want to memory right here. We don't even need that. Let's take that out. We don't need, actually we don't need, all we need is that function, I think. Oops. Let's see now, what is our, we're passing in mem, so it's what, new mem, yeah, that was right, new mem. I don't think we need that. Because we check our return code, our mem right here, so we just need, all we need is just the size. And we really don't need old mem. Yeah, if the mem is null, just allocate the size. If the size is 0, just free it, else reallocate that right there. That looks good. Okay, what does this one do? That's just a helper. Let's just get rid of all of this. Alright, next one. My free, we're gonna have to free memory. All we need to do is just free the memory. Or free that, yeah. All we need to do is just free that. And just take out the rest of this. Just free that memory. If it's not null. Okay, what does this string do? Okay, that's okay. Malloc. Okay, that's okay. My malloc size is 0. Okay, return, that's okay. We just need a malloc, I believe. Oops, wrong button. Let's see now. We just need a malloc, whatever size we were requesting. All right. Return the mem, yeah. Return the mem. And this is all those defines. So let's just start right here. And delete that. All right. Oops. FMD 2020 0908. And we'll restore that memory manager. And all the sizes are verified. And it took a long time to find this. I am going to delete. I'm just going to expand all those macros so I can look at the code and see what it's doing. Expand those function like macros. Okay, now let's save this. Go back over here. Alright, and let's make. There's our executable. So if we were to do the TDE, boom! There's TDE without that custom memory manager. There we go. There it is. Alright, so that was two methods of fixing that memory manager. One, use standard ints, and two, just remove the memory manager. When I was trying to debug this thing, it was just easier just to go ahead and remove the memory manager, the custom memory manager, until I could figure out what that code was doing. It was very difficult to figure out what that code was doing. The author, certainly when the author writes the code, he has he can remember big chunks of code, but other observers, they need to look at the code to see what it's doing. That just, it's not obvious what the code is was doing. So I do have this is the Google style guide, and this is a creative license, so we can display this. Let's look at the C++ style guide, and let's look at macros, what they say about macros. Should be 64 and 32-bit friendly. We just now use those 64-bit types. Let's see if we got some more info. Avoid defining macros. It's very macros mean the code that you see is not the same as the code the compiler sees. It's very difficult to debug those function like macros. I believe they actually have a kind of a snarky thing down here. Macro names. You're really not you're not really going to define a macro, are you? If you do, they're like this: my macro that scares small children and adults alike. And now this is Google's style guide. You can find that on the internet. They're a pretty large company, got lots of code, and I'm going to go by this style guide. Those function macros, function like define macros are very difficult to debug. All right, so that's what we did. We did 30. We compiled TDE in 32-bit and in 64-bit. And I'll put those. I'm going to put that code up there on my Google Drive. let's see, that's this one right here. I'm going to put those on my Google Drive in case anybody is interested. I would be cautious though. Let me put this up here. Warning. Be careful. I have not. I mean, there's still a lot of things in TDE, both the 5.1 and the 4.0, that need to be looked at. So if you do use TDE, be careful. I've got a lot of work to do, but it's just an ongoing project. So, but anyway, thank you for watching, and I'll put this on my Google Drive.